need to have it in that far. Right there. I mean, as long as those are protruding through the bore itself, that's as far as they need to go. This clamp here, finish clamping it in when it's all the way, and then it becomes part of the machine itself. Alright, so these are basically just to guide it. So what I do is I go ahead and I loosen my back one there that I got. This is just set here, semi-loose. I hardly ever tighten that one up there. And now we can come on down off of the chain ball and get that out of our way. And that can stay right up there. It always does. And all right, now we got those lubed, and we should be able to, yeah, we can push that in now. All right. I'm going to get that there like that, and get this like that, and the closer it gets in there, the easier it is to slide. And we got to make sure that our gantry's out of the way here now. And that's looking pretty good right there. Double check it again. Flashlight. Okay, and we raise that up just a little bit. Okay, it's sitting on the end of it. There we go. Alright, now to double check and make sure that we got it in there. Alright, we're moving it. We're not sitting there and slapping between those ways. Alright. Now I'm going to go ahead and get my Allen wrench and adjust those in. While we had it hanging there, but we want to put another drop in there, and I'm going to grab my grease gun and we're just going to shoot another bit of grease in each one of those. we're going to go ahead and we're going to swing it to the side, and we'll start setting up our stroke and everything else, and getting this thing dialed in. And we're going to go ahead and show you how to dial this in so it's straight in line with what we're going to be machining here. Alright, we loosen all of those bolts now, I believe. Yep. Okay, now I have the 90-degree line up, or the mark over here, and I like just using a rawhide mallet, just lightly tap it, and that's going to be close enough right there because we need to dial it in. So what we're going to do is we're just going to put an indicator mag base off of here, and we're going to come down on the top of our part here and pick up that straight line right there. We've already moved our table back and forth, and we had this dialed in. And we can test that run out and this run out all with one setup. Okay, and move the index head over a little bit here. We're done with these. I forget what we were using them for, but all right, and watching that stroke kind of, okay, we're going to be on the whole surface all the way now, and we can just come up a little bit here, okay, and then we're going to roll it in until we get the high side on our indicator here, which is about right there. We can set this at 0. Alright, and it's starting out at 0 out here, and it's coming in about a plus 3 or 4. We'll move you over so you can see this a little better. Okay, we're like plus 3.5 there. Okay, now let's just go ahead and we're going to leave it right there. Now we're going to move the index head back and forth that little bit there. Actually, before we move that, let's go ahead and stroke it again. Right there. Right there. That's pretty close, right? Alright. And of course that was 0, it's pretty close to 0, it's like minus a half there. Alright, our part is pretty square. Alright, so we're going to go ahead and we're going to adjust our head now. And we were plus over there. So that means we want to cock the head some more this way here. So we're going to go ahead and give it a light tap here in down position. Okay, and making sure everything's moving there or not. just went just a skosh too far. It was like 1/1000th difference here now. Okay, I like that. Let's tighten this up on here. Let's see what we got. Okay, I'm within a 0.5 right there. I'm gonna let that fly. Okay, everything's tight. Let's double check. Let's tighten down the table, tighten down that, tighten down the knee, tighten down that. Okay, let's set it at 0 right there. We're about minus a 10th or so. That's it. Okay, I can live with that. Okay, now we're going to go ahead and we're going to adjust our stroke length to give us what we need to create the whole length of bore here. Basically, we got 2 inches there, and I believe right now we're pretty close to a 2-inch stroke here. That is pretty darn close to 2 inches. Actually 2 1/8 is our stroke here. We're going to see if we can actually lengthen it at all. We have a slide down in here and a nut that we undo. We should be able to. That's good. That grease we greased in there, it really has gone down and gone around that crank, so we're doing pretty good. And on the outside of the slide here as well. Okay, we'll see what that nut size is right there. And it is 1 1/16. If I can put this in neutral and spin this where we want it. Okay, I'm going to lock it in right there. Just because I have no interest in smashing my fingers or anything else, and I'm going to wipe a little bit of this grease off of here. And I think I can increase the length of the stroke just ever so slightly right here by sliding this outward here. And that's going to be, I don't know if it can go anymore. I'm I'm just going to leave it slightly loose there, like that. And I'm going to take my indicator off of here. And again, I haven't never had this adjusted out to the max, or maybe I did have it to the max, and 2 1/8 is the longest. But I'm going to put this in neutral now, and I'm going to take my 1 1/8 wrench here, and I'm actually going to cycle this by hand back here if I can. There we go. And what I do with my scale, there it is. Okay, that's full out right there. And that's almost like 2 3/8 from where it was. Okay, right there is the beginning of the stroke. We just want to make sure that we're not sucking it back up against anything here. Everything feels like it's inside. I'm putting a line right there. Okay, and right there is the end of the stroke. Okay, we're at 2 7/16 of an inch of stroke right there, and I don't think I dare get any more than there. I'm holding the brake here. When you hold this back, you're holding the brake. Okay. Now we're tight. Now also look at the way that this head is offset and that pin is driving in, and the reason why they have that slide right there and how it passes. Look how the stroke going forward is slow and has the power, and then the return stroke coming back faster, just for speed wise. And that's in their design of this head, and just like the shaper and any of the other single stroke acting crank attachments and machines, that was theory. That was put to theory when they put them together in the stroke, just like on a locomotive as well. Tool is almost identical to the same kind of jumping jack, and that's where I get the name, or called it. That's on the back of the Bridgeport. That other pivot on the back side of the Bridgeport was for supporting a jumping jack back there, and I've seen a few of them, and they had nice dial adjustments on the side for your stroke and everything else. It was kind of a nice little compact package there. This is the only one that I've seen personally myself, and as soon as I laid eyes on it, I knew exactly what it was, and I was just in awe that I would actually have this for this K&T. And here again, I had this whole package pretty much before I even had a Bridgeport, and I was actually looking for a I say real mill, but I meant just a mill that can handle a little more weight, remove a little bit more material, and just really get her done. Now, you know, of course, if you're doing a lot of drilling and spotting different locations and you have a million different places to go, hey, the Bridgeport is the place to do it on. But, you know, in the mill, it's something. All right. Now we got to come up with a tool that's going to give us our shape of our spline. And so I'm going to be getting my gear tooth caliper just so that it helps us verify what we have in the teeth on the spline itself. Here's a couple tool bits that I've actually, let's bring it over here in the center. Alright, this one here was for doing a 3/16 wide keyway on a bronze piece. On the Gatling guns you'll see this tool in a photograph using a jumping jack. This is just a small boring bar, and you can always change out this bit right here, and this was like a 3/16 with a slight angle on it. And this one here was a 1/4 inch keyway, and I forgot what job it was, but I actually do have that one on video, and you see this thing actually coming towards you just like, see if I can get that angle right. There you go. Alright, we're getting ready to make the tool bit, and we've been down and we've played around with the shape on the spline itself. We know that the tooth height is 165 thousandths. The tooth across the top is 210, and the width across from root to root is 312. And we did that with our gear tooth vernier calipers, and we even used our magnifying glass. I mean, we have perfect sight with our glasses, but this reading these lines and everything else on a small tool is still easier with the magnifying glass. And it is fun to play with one of these. I was given this one, and so here he gets to see me use it, and even though I'm just using it as a reference in the project here. And anyhow, I still haven't come across another locking screw for that part there, but most of the time this is locked and this is locked, and you're adjusting it here. And it's not a high priority to lock these. This is a pretty firm tool. It doesn't like rattle around or anything else. So anyway, we got a piece of 8620 here, and we kind of keep this around ever since we started making tools for this, because this 1/2 inch diameter is perfect for fitting in here. Now this is a 1/4 inch width here, and I had this for a 1/4 inch key, and you saw this in another one of my videos. And I don't really want to destroy this, and I want to create a new cutter for this, and because I want to grind those two angles into the cutter. Now I'm not going to make it a full 5/16 wide and exactly the shape of the tooth, because I want to come in and have tool clearance to the finished diameter, and I want to come in and I'll whittle back and forth, but I'll get the depth and then come over and kiss one side and then kiss the other side, and I can move back and forth to create the slip fit for the spline that we're going to want. And so I have two pieces here. Now this here is a Cleveland steel, and it's actually it's already pretty well ground, and I think I was doing some plastic work with this, so it has a real steep nose angle. That's not what you want for shaping or broaching. You want minimum relief behind there. Just like the tool bit I made here, this is actually got a drop of clearance here, but right at the edge there I just kissed it off with a little less angle. The least amount of angle relief behind creates a stronger leading edge on your tool. Okay, so even if you have a lot of or steep relief right up next to your edge, flatten that out some. Not all the way, but flatten it out to where it's as minimum as you can get by with, and your tool bit will be stronger, and the cutting edge will last longer. Alright, so what we're going to do is we're going over the lathe, and I'm going to cut, and I figured the actual length here that we wanted to work with out here, this is a good length, so I'm going to go ahead and part this off. And while I'm at it, I'm going to go ahead and make a couple of these, because I like to have them on hand, and then I can just drop in the tool bit that I want and create the shape I want on them, and then just keep them in a little rack or whatever for this thing. I have about 3 or 4 of them. I have them in that super safe spot. That's even safe for me right now. All right. Alright, we're just giving a couple of these surfaces here on the nose here a clean face. We want a square butt at the bottom where it rests on in the holder of the slotting head. So creating a square end on both ends very helpful. One, because just so you don't accidentally machine the slot into one that leaves a dimple on it. Alright, we're doing a couple different things to investigate or create this shape so that we know what shape to put in our tool bit to create the grooves in the inside of the bore to receive each one of these teeth. And then of course we're going to be putting 14 of them in there, and we got the index head that will keep us in line on that. We've taken our monkey shit here and formed it down in here, and it gives us a shape that we can eyeball. Now, of course, this is a tool bit that I made with a 1/4 inch for a 1/4 inch keyway that we put in one of our jobs. And I'm not going to mess this up, but I'm going to make an exact replica of the stem and everything, because I bought a stick of this 8620, and I use that because it's harder and more durable for making a push tool than general cold roll material. So I like the chromoly and other added alloys in here that create a little bit firmer rod, and it's not affected so much by the silver brazing on my high-speed bits and stuff like that. The high-speed bits are made to take heat and temperature, and by silver soldering one on here, you're not changing the hardness of that tool bit enough to be concerned with in any capabilities of cutting the material that we're working with. And we're going to be, this is the piece that we're actually cutting is going to be is a piece of 8620, because I want that tool to be firm. So the only problem I've ever had with silver brazing a tool bit in place, and I had to move it a couple times, and I got it real hot, and I was impatient, and I over quenched it, and it shattered because I quenched it too hot. But by silver soldering and just letting it cool down normal, I haven't lost enough hardness in a tool bit to ever notice it. So, and anyhow, back to our molding here. with our monkey shit here. This kind of holds it in here, and then this gives you an eyeball that you can actually put your tool bit in there. Now of course we're going to be making the base of this we found, and how we found that is we went ahead and used our gear tooth vernier calipers, and we went ahead and adjusted this in until we were at the root, and adjusted in and out until we had the depth, and we ended up having 5/16 or 0.3125 at the bottom, and about 165 on the depth there. And we've jotted that information down. We've got our little mold here to just quick eyeball as we're playing around with our tool bit and angles and stuff like that. And then we also came in here with our Starrett bevel protractors and worked a couple different angles. And this is a used motor, so we got some slight bit of wear on the teeth already, so we're just averaging it out. But we got about 22 degrees on the actual tooth side there, and we know this is an involute spline, and we're just taking all of this information and kind of creating a form tool that we're going to be able to get in there and start making a groove, and then use that same tool and step it side to side and bring out the width and the depth to create the bore for this spline. And that's kind of what we're up to. Alright, so let's get back to making our tool bit, because we're going to go start grinding the sides of our tool bit and set up the shank of that 1/2 inch pusher that we're going to use, and we're going to mill a slot for the 1/4 inch tool bit so that we can braze silver solder it right in on center line. And I'll explain later why I want it to be set up as perfect, as close as possible to be in center. And we'll get onto that as we come about.